Okay, I think we're going to get started. First, I'd like to welcome everybody to the Platform Builder 212 session. My name is David Streams. I'm the program manager for Platform Builder, and I have Steve Fu here. He's our developer lead for Windows CE Platform Builder. We've got a lot of great things to share with you today that have come about with this new version, which we're really excited to show you. Start off with just a quick agenda. We're going to go through some slides just to give you a lot of information about what has changed with the new version of Platform Builder. So before we do that, I'd actually like to see a show of hands. How many of you have used the Embedded Toolkit or Platform Builder previous versions before?
That's about everybody.
Well, about half, three quarters. That's great. So what we're going to do is, throughout this presentation, make sure that we can help you apply your current experience with older versions of the product with what's new, so that you can quickly get up to speed on the new features, etc. I should also point out that a few people have asked me where they can get the Platform Builder preview. I'm being told that if you go down to the where you got your materials pickup, there's actually a separate survey that you're supposed to fill out, a white sheet, and then you'll get your preview. So if any of you haven't gotten it and would like to try out Platform Builder 212, I encourage you to go down there after this and pick it up. After we go through the slides, which I don't want to spend a lot of time on, we're going to do a lot of different demos. We're going to actually take you through the Platform Builder IDE. We're going to configure a platform. We're going to export an SDK, and we're going to end the day with showing the new IDE-based kernel debugger. So with that, why don't we go ahead and start? The main features in this newest version of Platform Builder revolve around the integrated development environment. Since a lot of you have used previous versions of the Embedded Toolkit or Platform Builder, you know that we had an IDE, but the IDE only supported component development. If you built your own custom component or application, you could use an IDE which was based on Visual C++, therefore familiar to any of you that might have done Windows programming. But what we didn't do in this IDE was allow you to configure, build, debug your operating system. So that's what this release is about, this new IDE that lets you configure, build, debug your OS. We also put a lot of emphasis on this feature called Export SDK, which will enable the millions of Windows developers to target an embedded platform without having to have embedded expertise. They can just apply their expertise in Win32 development and, again, target your platform. And we'll go through that with a demo. We've also been listening to our customers. We found that through customer feedback, some feedback that we've gotten is that we wanted richer documentation. That's more focused on depth, quality, etc. So I think you're going to find in 2.12 version of Platform Builder that our docs have been beefed up. The fourth point for Platform Builder in terms of new features is an extensible catalog, and we'll describe in more detail what the catalog is. But basically, think of it as a repository for all the possible components that you can use in your configuration.
I'd like to add a little bit to what Dave said about the change in the IDE to the build process. For those of you who are familiar with the command line environment, we are not taking it away. In this release, if you feel comfortable with the command line environment, it's still there. You can steal it.
Very good point to make. So let's take a quick look at the IDE itself before we go into our demos. The first new element of our IDE in Platform Builder is something we call a platform pane. And the platform pane has a couple tabs in it. The first one we're going to talk about is a component view. The component view is a list of all of the components that make up your platform. The other thing that's interesting about the new IDE in this view is that we save the state of your platform. In other words, all of the different build rules for your components, the settings, what components are in your platform, etc., are saved in a workspace.
Yeah, a workspace is an analogy to Visual Studio or Visual C environment as a project. But this project, we named that as a WCE workspace. It's specific for your platform instead of for a particular component in the VC sense.
Perfect. The other thing we allow you to do, in addition to configuring existing components, which you do in the platform view, we allow you to build your own components. And you do this in the project pane. And for those of you that are familiar with Visual C++, you'll notice a parallel here. The IDE for building projects, or custom components, if you will, is very much like Visual C++. You have the ability to lay out your project, have a file view. You can have class hierarchy view, resource view, build, everything that you know from Visual C++ really applies in this project pane. And like Workspace, we also have the project state saved.
Yeah, some of you might be confused because in the last slide we said something about WCE Workspace will save your platform information. Think about it as a hierarchy structure that the WCE represent your platform, which have many nodes. Each of the nodes could be a custom component or a PBP project, which is a full VC++ sense of project that you have all the class view, file, all kinds of project development facility.
So maybe whatever static components we have in our platform are saved in the WCE, but then I might create a custom component, and that will be represented as and saved as a PBP, or Platform Builder Project. And again, that's analogous with the Visual C++ DSP project.
Exactly.
And again, when you build this project or this custom component, it's going to build it against your current platform. So when you configure your platform, there's really a couple of things that you can do. You configure using existing components. We're going to take you through in the demo on what's called a new platform wizard that helps to pair you with a board support package, or in other words, the OEM adaptation layer and hardware drivers that you need for your particular hardware platform. It's going to pair you up with one of the 8 standard OS configurations. From there, you can add additional components to your platform using the catalog, which again is a repository of additional components which are available to you. An example of components that are in the catalog that ships with Platform Builder would be runtimes for supporting C++, like MFC or ActiveX template libraries, or perhaps Visual Basic. It's also extensible, and we'll talk more about that in just a few minutes. You can also import projects, sources, and DIRs into your platform. And then, of course, as I mentioned, we support the notion of creating new components. And you can create a lot of the same components that you can in Visual C++, the standard XE, statically linked or dynamically linked DLL, console apps, etc. And again, all of these custom components that you create inside of Platform Builder are stored in a Platform Builder project, or PBP. So let's talk a little bit about the new platform wizard. And again, we're going to see this in just a few minutes. It provides a starting point for configuration. Instead of just setting you loose and saying, figure it out, we thought what we would do is package it up in a wizard and allow you to tell us what you needed, or be able to select from some defaults. So for example, for board support packages, we support 2 out of the box. A CEPC, which is what we're going to use in our demo, which is just an x86-based target where you can use standard off-the-shelf hardware, and we supply a number of drivers to support these configurations. Or an ODO, or a D1000, which is a 100,000 gate FPGA. Those 2 are supported as standard support packages in this platform wizard. But the platform wizard is extensible, meaning that you can add your own custom board support package and it will be recognized by the wizard. So this is just a look at the catalog view. So again, it contains a superset of available components. When you go through the new platform wizard, we're going to give you you're going to select a board support package and one of the 8 standard CoreOS configs. From there, if you want to add additional components, those components can be grabbed from the catalog. They can be created outside of the catalog as well. The catalog really is a logical abstraction of components. It isn't like a physical file exists in the catalog. The catalog contains logical descriptions that are categorized. We call them types. So one type may have many different implementation options. When you select a particular implementation and you bring it into your platform configuration, it becomes a physical component. And the catalog is extensible via what we call CEC files. So you can write a text file containing metadata that describes your component and then import that as a component into the catalog.
Some of the metadata include things like in each the build phase, what you're going to do to build this component. Some of the other things like friendly name, things like that. I want to emphasize that not everybody needs to touch your catalog. Only for those OEMs who really want to ship your software component to somebody else. You want to integrate your component as part of the platform builder, then you probably want to spend some time learn the concept behind the CEC and catalog and trying to integrate this into our environment.
I'd also like to add in the slides that I believe are printed out and handed out to each of you there's a sample CEC file in the back so that you can look through and figure out exactly what makes up a CEC file and how it's defined. Next, I want to shift to the build process. So for those of you that have used Platform Builder or the ETK in previous versions, you're probably familiar with this, but I thought we would readdress it for the benefit of those who have not used the product. There's really 4 phases of the build process. The first phase is sysgen, where we're going to generate system headers and libraries. Next phase is build, where all of your applications and board support components are built. Third is build rel. So after the sysgen and build phases, there's lots of files which need to be copied into what we call a flat release directory. And then finally, make image bundles files up into a single file called an NK bin. And make image basically utilizes some text files, like a bib file, a binary information builder file, to designate what files are going to be into the nk.bin.
Yeah, for those of you who is familiar with this process, this is probably no news to you. In the IDE, we try to wrap this process to make it a component-driven fashion, in the way that each component listed in your platform could contribute something to each of this build process, or I should say build phases. So for sysgen, only core OS can contribute something to it. But for the rest of the 3 phases, each of the component can do something. For example, your component can decide in the build rel phase, you call custom step to do some custom copy.
So we're actually enabling, with the new version of Platform Builder, a componentized build system. So each component can have its own custom build rules.
Yes. If you remember the catalog, how does the catalog magically help you do the build? That's what happened in the background. When you put a component from the GUI, from your catalog, into your platform, that meta information about how to do build is automatically dragged into the platform.
Perfect. So to talk a little bit more about the sysgen process, we thought we would look at it 2 different ways. The existing command line environment versus what happens in the IDE. So in the command line, you modify csysgen.bat to determine what modules are built in this phase of the build process. But in the Platform Builder IDE, we make it very, very simple. You can right-click on the platform, select Settings, and there will be a list of checkboxes. And you can very easily add or subtract features from your Core OS component through the IDE. And here's an example of a screenshot of what that's going to look like. And we'll actually go into more detail in the demo to show what this looks like. In terms of building individual components, this is where if you're building XEs, DLLs, drivers, etc., these are built, as Steve mentioned, individually. So in the old process, do you want to talk about the command line, how this differs from the command line process?
In the old process, some of you may be very familiar with it. You create your DIRTS file, which will build everything that you can conceivably build into your platform. In the IDE, you don't really have to do that, because as long as you say each component, how to build that component and drag that into your platform view, you should be able to just build it right there. So you don't have to modify your DIRTS file on your own. But if you prefer the command line environment, the old facility is still there.
Talk about make image a little bit. So as I mentioned before, make image utilizes a number of text files to, for example, the bib file, which is where you designate if a file is going to be added to your binary image or your ROM image, your NK bin. There's a notion of reg file, which is where you can set registry keys for a particular component. Dat files define dir and file location. DB files define database files. So what we've done is we've taken all these files and abstracted them into the IDE, so you can quickly select a bib file, for example, double-click on it, and modify it within the IDE, and save out the changes instead of manually doing it from the command line. There's also the notion of global environment variables. So a moment ago, we looked at the sysgen tab. When you go to the platform settings, you look at the sysgen tab, and you can add or delete Core OS features. In the environment tab, this is where you can define global environment variables. One example would be to enable debugging, where you need a debugger stub. You can set a global environment variable so that the make image phase will take that component, which is already in the flat release directory, and put it into your binary image. So there's a couple options whenever you're building your component. You can, well, I guess we should probably save that for the demo. It's probably more clear there.
Yep.
Custom SDKs. So why would you want to do this? A lot of people think that software development kits are mostly for products, targeted products, like for a handheld PC. If we build a handheld PC and I'm a software vendor, an independent software vendor, and I want to build an application for that platform, yeah, I'm going to need a software development kit. But I'm an embedded OEM. Why would I ever want to use an SDK? Well, one of the key reasons you might want to consider using the export SDK feature is for collaboration. If you want to enable, again, these Win32 developers to target an embedded system and apply their skills without having to know anything about embedded development, you can do that through the SDK. So the SDK, or the export SDK feature, rolls up the applicable components for a particular development tool, for Visual Basic or for Visual C++. So the export SDK feature is specific to a language, and it's extensible. So today we support an SDK feature for both Visual Basic and Visual C++. The needs of these developers are different. So Platform Builder exports different things for a Visual Basic developer than a VC developer. VC developers need things like headers and libs. A Visual Basic developer needs something like a VB runtime and to know what ActiveX controls are supported on their platform. The other thing an SDK packages up is information about the transport. So it tells the development tool how to connect down to the target, so that literally the application developer can install a single file executable, and the SDK will install, allow them to easily target the platform. It'll also tell them how to connect to the platform so that they can build an application and download it to your embedded target. Another thing we're changing in the Platform Builder 2.1.2 product is our debugger strategy. In previous versions, we've actually shipped 2 debuggers. We've had an integrated debugger, which is great, an application debugger for debugging applications, and then we had a command window-based kernel debugger called WinDBG. In the new model, we're going to have a single debugger, which is a kernel debugger, but it is integrated into the IDE. And we're going to go into much more detail in the demo, and I think it would be more interesting hands-on. So with that, let's get away from the slides and actually go in and start using the product so that you can get a feel for the flow, how you configure a platform, build a platform, etc. And then at the end, we'll go ahead and take questions. Oh, we're up. We'll do it when you boot it. Okay, so if we look on the right screen, we're looking at the new Platform Builder IDE, and of course this is an empty project, so there's not a lot to see. So why don't we start by creating a platform? So
okay.
If you go to File, New, this is our platform wizard, which we spoke of earlier. First thing we're going to do is name our platform. So what do we want to call this?
Let's go to DevCon.
DevCon? Okay. The other thing we're going to do here is define what processors we're going to target. Now, we've only listed 2 here, x86 and SH3, but Platform Builders ship support for all CPUs. They're supported with Windows CE. There's perhaps a point I want to make that isn't clear in this demo, and that's that one of the pieces of feedback we got was that the setup for Platform Builder is very difficult. If you just were an OEM and you knew you'd done the selection of the processor you wanted and you just wanted to install the tools, binaries, sources for that particular chip, it was very difficult. So I encourage you, if you're using the preview, give us some feedback. We think we've made it very, very easy to just install the CPUs, whether it's one or all. Make it very, very easy with just a few clicks of the button.
Yeah.
So
I'm sure some of you will appreciate that because the Platform Builder CD has reached 8 CDs. And if you install all of the CPU, it's going to eat up a few gigabytes on your hard disk.
Just a few. So we're going to target x86. As I mentioned, we're going to be building an image for the CEPC platform. So the next screen here lists all of our board support packages that we have available. So at the top, you're going to see CEPC and the Odo, which we support out of the box. But notice that there's a third one here. It's called Sherry. So how many of you have taken the Platform Builder lab downstairs? So the people that did would know that there's a board down there also called Sherry. It was designed by Ezos. It's running SH3, lots of different peripherals, etc. The point is it's a custom board and has custom drivers, OEM adaptation layer that was built specifically for that platform. And they created a configuration so that they could add their board support package to Platform Builder. So Steve, what does that mean if I add a board support package to Platform Builder?
A BSP or board support package really means 3 things. First, you need to have an OAL, which is linked into the kernel. And the second thing, you want to have a set of driver is specifically run on this particular hardware. And the third thing we enable people to do is when you say, I build something for this particular BSP, what kind of default component we're going to pull in. For example, if you have 5 different display drivers for CPC, we're going to pull in one of them as a default. So that's the information you can specify when you provide this BSP. And we provide a way that if you really want to integrate into this IDE, you can provide your own BSP file so that your BSP will show up in the list, enable your user to create a platform based on your hardware.
So you create a BSP file, and that enables you to see the board support package, and the resulting platform view will have the default drivers. And then you can also create CEC files for each of the other board support components so that it's in the catalog as well, correct?
Actually, it's the other way around. The BSP package references the component. So in order to enable for your hardware, you need to import your component first, and then have the BSP file reference to them.
Perfect. And there's documentation in Platform Builder that explains to OEMs how to do that as well.
Yes, exactly. Again, I want to emphasize, not everybody needs to do that. If you only want to use a platform builder to do something for your platform, you don't want to bother doing that. But if you want to ship something, deliver to your customer who want to use PB, do something on your platform, then you want to do this.
Perfect. So why don't we select CEPC, go to Next. So now we're looking at the next step in the wizard, which is to match us up with one of the 8 sample OS configurations. So right out of the box we say, well, maybe you just want a minimal configuration, which is called minkern, and that's just a kernel and minimal file system needed to boot. Or you could go with just the maximum, which is Maxall, and that has a lot of things in it, Pocket Apps, etc. It's a very full-featured OS. But at the same time, we wanted to give OEMs, especially new folks that haven't, experienced Platform Builder, they haven't looked through to understand each of the 8 configs, we wanted them to be able to define what features of the OS they wanted, and then let Platform Builder match them up with the most applicable configuration. So if we select Custom and hit Next, we're going to get a list of some of the features in the OS, and we can just check off what's important to us in our platform. So why don't we go ahead and select a couple components.
I want to explore for my platform.
Okay, so if we just explore, that's
Yeah.
all that's important.
Yeah.
Okay.
Yeah, of course. Internet.
There you go. So hit Finish, and basically it's going to say that the best configuration for this is IE sample, but I think we forgot some. We wanted to get Pocket Word, didn't we, in our configuration?
Oh, picky.
Well, So if we go back and we select Pocket Word or Pocket Applications and hit Finish again, it's now going to determine, well, IE sample doesn't have the Pocket Applications, but instead of making you know that, you just tell the wizard that you want Pocket Applications, and it's going to tell you that Maxall configuration is the best for your application. So why don't we go ahead and say OK. Now, something seems to be happening under the hood here. What's going on?
Yeah. For those of you who use a command line environment, you may remember this. If you do something based on Maxall, you probably will most likely start by creating your own platform directory under the project, and copy all the Maxall stuff into your directory, because you don't want to mess up with the Maxall config. Later on, when you want to do something else, you want to base on your Maxall again. So all these things is now happen under the hood. IDE handles all those for you. If you examine the file system, you can actually see these things has already been created for you. This is our WinCE directory, and under the public, CEDevCon is created, and things here is copied from the Maxall directory into your particular directory. And you can also see the project file we mentioned before is created for you.
Perfect. So it automated all the manual steps that we had to do in the command line prior.
Yes. Mm-hmm.
Great. So now why don't we show the tree there? We expand the tree. So again, this is our platform view, and platform pane, particularly our component view. So we're looking at all the components which are currently in our platform. So you can see that we have the CEPC OEM adaptation layer, a set of drivers, a Maxall Core OS component. Let's say we want to tweak the Maxall Core OS component.
Yeah, you can actually see what you have under Maxall by expand the tree. If you want to tweak it, we go into the setting.
So you right-click, you click on Settings, and there's a SysGen tab.
Yep.
So what if we want to remove, I changed my mind. I don't want Pocket Word anymore. How do we get rid of it now?
Oof.
I'm just a PM, man. I change my mind all the time. Yeah. So you can just unclick the feature that you don't want in the CoreOS component, and then when you actually build the platform during the sysgen phase, those modules will not be built, not included. So
in fact, the GUI reflects the change you have.
So how would we have done that in the command line, Steve?
In command line, if you need to make this kind of change, first you have to look up the menu, see what are the environment variables defined for Maxwell. There would be typically something like Maxwell underscore know something, and then set those environment variables.
So I'd find the environment variable for Pocket Word, and then I would set that so that sysgen didn't include it. So I'd set a manual environment variable.
Exactly.
Perfect. Okay, well, you know what I noticed here is that that board support package that the wizard gave us the wrong video driver for our CEPC configuration. So,
did you bring the wrong CPC?
Well, yeah, I did. So let's go ahead and delete the default driver and show people how we can add a new video driver. So first off, where do we get the new one from?
Okay, first of all, you bring up your catalog. Again, catalog has all the components we shipped and also some of the third-party add to your environment. So in this case, a CPC driver has a whole bunch of things here. If you go down here, you can see there are multiple video drivers here. Let's delete the one in our platform. You highlight this and hit the delete key on the keyboard.
Great. Now I know I want the Verge card, or the Verge driver, so how do I add that to my platform?
You can select this component, right-click, do add to platform, or you can drag it over.
Okay.
So it's here.
Okay. So now we're at a preview stage. How do I have to do anything else now to add that driver to my image?
Yeah, there are many things. Let's review this platform pane. Many things happen under the hook if you go to build menu saying build platform. Many things will happen. What controls that is all controlled by the build settings in each of these components. In this particular case, let's look at this particular driver we just add.
Okay. So again, these are the build settings for a particular component.
Yes.
Okay.
Depend on the node you highlight. For example, if you highlight the Maxwell node, you see the sysgen setting because only CoreOS component can contribute to the sysgen build. Right. And if you highlight this driver, you have a custom build. Remember the 4 phases we said? The first phase is sysgen, and you have like 3 other phases. And for the component build phases, this component using the sources makefile you are familiar with to build its component. In the make image phase, it does nothing. But I think this is probably wrong because, as you might remember, in order to enable this driver into my image, you can go to your platform bit file.
So we need to get it into our nk.bin.
Exactly. And you can see the driver we want to get in is this one. This bit file has if here. So in order to enable this particular DLL into our image, we need to define this environment variable. So let's define it. So
it looks like right now, Steve, we're defining it on a component level. So we're saying we're creating a custom build method for this component to actually add it to our nk.bin.
Yes, exactly. The way you do it is you go to a setting, and in the make image phase, you want to say, I want to define a environment variable like this as 1. That will enable this thing in the bit file. Notice that the catalog is capable of helping in the case that when you drag this component, if this information is in the catalog, then you don't have to set it. In this previous state and also for this demo, we didn't set it so we can show how this thing happened.
So when the product actually ships, we could possibly have a custom build method already defined for the Verge driver so that it would automatically be added to our nk.bin by having a custom build rule associated with it.
Yes, exactly. So it will be all GUI that you drag this component, it ends up in the image.
That'd be pretty cool. Is there anything else we could do as an alternative to add that driver to our image?
Yes. For the things we change, we make a setting tailored to this particular component. So it's add when this component is add, it's remove when this component is removed. You can also do things on a global level. If you are really familiar with the old environment and don't want to think about all this, then that's the global environment tab that you can set all your environment here.
So we could just set the same environment variable to 1 in this environment tab, and that would be a global setting for this driver.
Yeah, for example, you can do the same thing and set it will be here. and it will trigger the same thing, but apparently we already set that on the component level, so we are not going to do that.
Okay.
I'll cancel this.
Great.
Okay. So at this point, if I go to build and say build platform, all those 4 build phases will be kicked off. By the way, notice that we have this platform config tab. So you choose your config tab to decide which config you're building against. So,
if you want a full set of debug symbols, you'd select x86 debug, for example.
Yes, exactly. And also, I want to make a note here that in the general tab, you'll see that we make a slight change from the command line environment. In the command line environment, you change your flat release dirt by setting an environment variable. Now, IDE is doing all that for you and help you to maintain different set of flat release. Particularly, we have this particular platform called CEDevCon. Under release directory, we tailor your release dirt to your current config, which is debug. So if you switch to a release build, it will be another release dirt. That way, you can maintain 2 different sets of release dirt without stepping on each other. And that's the change that you might notice.
It's a pretty cool feature.
Mm-hmm.
Okay, so for the purposes of time here, if we were to build this Maxwell platform, it would take probably 15 or 20 minutes. So what we've done is before you've arrived, we've actually built the same platform, a Maxwell config, same set of drivers. So we already have an NK bin in our flat release directory. So the next thing we want to do is show taking that NK bin and transferring it down to our CEPC target and running it.
Yep. The way to do it, I'm going to open a previous workspace that I opened.
So this is kind of an interesting point then. So you're loading in DevCon 1 works platform. Mm-hmm. And so it's, again, going to bring it up in the state it was when you saved it. So it saved the entire state, all the settings, build rules, etc.
Yeah, exactly. It saves all the changes you make. And click on that. It's going to close the workspace I had and then open a new workspace.
Great. So how do we get the image down to the target? Is it the same as it was in previous versions?
Yes. Nothing has changed in terms of download and kick-off execution on the target side. So this is a platform. It's exactly the CEPC and configuration. What I'm going to do next is going to bring up my download environment. Some of you may already know how to do this in PB211. We are going to try to kick off a download through Ethernet. So first thing, I need to set up my environment.
So you just created a little batch file for this to set up your environment?
Two things, notice that I have to set my wins root, because in this version of the IDE doesn't rely on this environment variable anymore. But if you go back to this command line, you have to set it yourself. And also, I set my flat release dirt to the right one. And then I switch to my flat release dirt. And the next thing, I'm going to kick off the eShell.
Okay, so what does eShell do, Steve?
eShell is just a tool that enable download and debugging on the Ethernet.
Perfect.
And I pick my right CPC. Let me verify my option is right, and the image is right. Okay. The next thing I'm going to kick off a C shell.
And the -E is for Ethernet, and then you give it the machine name?
Yeah, the machine name is exactly the same one on here.
The address that it has? Great. Okay.
You can see a message here saying this is registered.
So
now the next thing I'm going to do is reboot my CPC.
Yep. Okay. Okay. So how do we boot the CEPC machine?
CPC is just x86 hardware that for those of you want to get some chip device that to test on some of the CE features. And we are going to try to kick off the eBoot. The bootloader will be trying to get an image from Ethernet.
Great. And I should say that the Platform Builder documentation also has examples of how to create a boot disk for CEPC. And I think several vendors are actually supplying off of websites easy ways to order CEPC. So it's really a cheap way to get started. Even if you're not doing an x86-based design, for a few $100s, you can put together a machine to configure, test, build the Windows CE operating system.
Yes, exactly. So now this download is finished, and we can actually see the image is running on the target side.
Okay. So now we have a Maxwell image, and on the right, we're in a CE shell environment now. So what kinds of things can we do in the CE shell environment?
C shell, I am not very good at C shell, but
I'll give it a question mark, and there's some onboard help here. Basically, you can download or start processes, kill processes, set debug zones, look at the threads that are running, etc. So
now let's see what's the process running on the other side.
So GI proc will show you, for example, all the processes that are running down on that CEPC.
Yep.
So why don't we switch back to Platform Builder now that we've got CE Shell going? Because what I want to do is quickly add a user application, because we haven't really shown that feature off yet. So why don't we just add maybe a simple Hello World app?
You want to show off a little bit? Okay.
Well, I wouldn't say showing off. So we go to the Projects tab.
Yep. This is the component we just said is a PvP project. The first thing we're going to do is we're going to create a Hello World application. It's real simple. We're going to call it Hello.
Let me just make it as simple like a console app or something.
Oh, I already have that. Okay, maybe I'll trade you another name.
I'm going to create a console app.
Oh, yeah.
So you select the type of app, and you notice that there's a lot of the same types of applications that you can create in Visual C++, but Visual C++ still has a lot of application-specific additional choices. So MFC applications, ActiveX controls, etc. So can we switch to our project view then?
Yeah. What we do is we create a console app. If you look at your component view, you can actually see there's a new node added to your platform.
So it's added the Hello XE as a new component in the platform view.
Yes. If you double click on this node, it's going to bring you to the project view. Or there's a switch here saying you can switch on platform view or go to the project view. So I'm going to click on this. Now I go to this project view. This is the very familiar with this C++ environment. Let's bring up the source code. That's a simple source code. And here's what the wizard do. So right now, I'm going to notice that it also has two different config. You have to build the same config for the same platform. So if you go to build, say build hello, the first thing it do, it's going to check if your platform header is up to date. So for those of you who's familiar with this, that really means that you have to generate your system header before you can build this platform. So it's going to check for that first and then kick off the build.
So if I would have tried to build Hello when I started my new platform before I had built it, there's no sysgen headers or libs, so it would tell me that I have to build the platform first, or at least generate those system headers.
Actually, the system will kick off that process for you, so generate the header for you. That means the first time if you build any project, it will take a little longer. But the second time, it's going to tell you it's up to date.
So now can we use a file system to run Hello?
Yeah, we could, but notice this is a command console app. If you just run it, it's going to open and then disappear.
Well, why don't we put a little sleep in there, or sleep for 5 seconds so it doesn't just like pop up and pop down?
Wow, I'm impressed.
Yeah. Dev's always giving program managers a hard time.
Okay, we're going to rebuild this thing.
Yep. So we're going to rebuild the project.
And you can see it's compile and link and then copy to the release dirt. The next thing I'm going to do is I'm going to start my Hello app.
So to start an app, there's a command, just S, and that means start process. So S space hello, hello being the name of the process, and we hit enter, and the file system will download the Hello World application to the CEPC and run it for you. So it's kind of convenient because you don't have to actually rebuild the entire image, re-download it to the device. You can just use a file system in CESH to quickly execute those applications.
Okay.
Pretty cool.
Yep.
Okay, so now that we've done this, did you have a couple more remarks on that?
No, I think that's it. Let's close the download environment.
Okay. So the next thing we're going to talk about then is now that we've got a platform that we've built, that we know works, we've downloaded it, now we want to enable, I wasn't too impressed with the Hello World app. I think an application developer could probably do a lot better of a job with it. Maybe even use MFC or something that would make it a little bit flashier. So why don't we export an SDK that then we can give to an application developer?
Yep, let's try that. First thing you do is switch back to your
component view?
Yeah, platform view, and go to platform and say export SDK. We're going to pick VCCE. So
this first screen in the export SDK feature is just a licensing screen. So the theory is that when you put together your platform, you're going to be creating your own components, as well as shipping some components that were provided to you with the OS. So you can create a license agreement for your particular components or IP that you've created and distribute it with the SDK. So why don't we click Next. Next, we can select what features we want in this SDK for Visual C++. So why don't we enable it for MFC and MFC ActiveX controls, and just leave it at that and hit Next.
This step is trying to pick the matching config because Platform Builder is treating the config a little differently than VCCE. For example, in this case, Platform Builder say this Win32 some config, and in the VC world they call it something else. So it's give you a chance to remap this.
So it's kind of pairing up what the Visual C++ developer will see versus what is reality for the platform developer. So we built a release config, and that'll be expressed as a WCE x86 project in Visual C++.
Exactly.
Next screen is our transport screen. As I mentioned, one of the things that's pretty important is that when the application developer installs the SDK, they need to be able to connect to the target. So we have what's called a framework called Platform Manager, which enables the tools to connect to an arbitrary target. And we ship a couple different samples of TCP and PPP transport there for you that you can include in your SDK by default. Moreover, we include a wizard in Platform Builder that enables you to create a custom transport based on the Platform Manager framework. So you could create custom transport for USB, for example, and include it in your SDK. Hit Next. It's next going to ask us where we want to download this SDK to. Again, it's going to wrap up everything it needs, all the headers and lib sources, etc., that we've defined for SDK, and put it into a single file, self-installed .exe. And this is just telling us where it's going to put it and how big it's going to be.
Yep. This is going to become a self-extracting executable that the VCC user will be able to just run and install the SDK on their desktop.
Okay, so much like the build process, what we did before you arrived, for the sake of time, is we created an SDK based on this platform, and I gave it to our resident application expert, Jonathan Tanner. He's the program manager for the Windows CE toolkit for Visual C++. So I'd like to ask him to come up and actually give a demo of using Windows CE toolkit for Visual C++ combined with the SDK that we just created for this particular platform. And he's going to build and download an application for his app, for our platform.
Thank you, Dave. First, I want to just highlight a little bit about how much you can partner with the third-party ISVs, so that if you are hardware-centric and you don't have a strong Win32 background, there are a lot of people out there that are willing to do the development in the higher levels with MFC. And now that we do have this export SDK features for VC and VB, you can now have them help you get the particular apps for your platform up and running. I'm going to have you switch me over there.
Which one? 3?
5. Thank you. Okay. Right here I have the 6.01 preview VCCE installed. And as Dave mentioned, to save some time, I've already installed the SDK. I'm now going to create a new project. And if you're familiar with the VCCE toolkit before, you'll notice that all the wizards are pretty much gone for Windows CE, well, except for this one here, the Windows CE wizard. And I'm going to click that, and I'll show you in a second what it looks like.
So you're going to create an application called what? DevCon?
DevCon 3 is what I'm creating.
DevCon 3.
Yep. And here you'll see the new Windows CE project wizard. What we've done with this is used to be that all the wizards were always visible, but you couldn't identify what platforms were associated with each wizard. So you'll notice now in the DevCon 1 SDK that I've installed that the basic, Windows CE applications and the MFCs are present, but the ActiveX controls aren't. If you look at like one of the HPC Pro, you can see the full list of all the wizards available.
So when I built my SDK in Platform Builder, I basically expressly checked off what features I wanted to enable for you. And then when you install the SDK in this wizard that you're looking at, it'll actually enumerate what features are available on this platform.
Exactly, and it'll give me a very good idea of what I can and cannot use.
Perfect.
And being a knowledgeable person of how development happens, you've been nice and included MFC for me because I really like MFC. In fact, 80 to 85% of all Visual C developers want MFC on CE if they're going to develop apps. They can do it the other way, but they much prefer to have the appropriate MFC classes there. If you'll notice also, there's only the one CPU showing up over here, the Windows CE CPU. Now I'm going to go ahead and generate my wizard here.
Yeah, something is happening with the projector.
Switching over to my other CE PC here. And I'm going to go through and create a single document interface. MDI is not supported if you're familiar from the desktop, but the dialog and SDIs are. And I'll accept SDI. I'm going to take the Internet Explorer rebars. If you're worrying about going and porting your apps back to older versions of the OS, you might want to stay with the MFC 2.0 compatible command bar. But if you're dealing with an embedded device, you know exactly what the hardware is going to be, so you can take full advantage of every feature that is present.
So these are just MFC classes which are available to me?
Yes.
In default?
Yep. And I'm also going to turn on a status bar and printing, because the OS supports that now as well. So I'm going to go through, continue accepting the defaults here, and accept the classes as they are, because they appear fine. And it will now generate the appropriate MFC application for me.
So you didn't have to write any code, and you already have a compilable application.
Compilable, runnable application. And it provides a very easy framework for your app developers to begin creating, or if you yourself want to start developing applications. And it also doesn't have the clutter of all the other like platform builder keys associated. I can just concentrate solely on application development without tripping up on platform configurations. I don't even need to think about that right now.
Great.
So I'm going to go ahead and build a release. Well, excuse me, I have to first do one thing because I want to release my product to the flat release directory. So as opposed to having it go down over an Ethernet or a serial link, I'm going to actually just have it go to a flat release directory just like Dave did with Steve, and then have the application start from there. So I'm going to go to project configurations or settings.
So you're basically just going to, when it compiles this exe, it's going to compile it down to the flat release directory, and then we're going to use CESH to download the app to the target?
Yep, and then it'll execute it there. And all I have to do for this is I'm changing my output file name to use :/utilities, and then put the name of the exe, which is, in this case, devcon3.exe. And that's the only change I need to make for this. And now I'm going to do a rebuild all.
Do you want it for debug or return? So yeah, it does really look like Platform Builder in the project view. In terms, you have the three different tabs: class view, file view, resource view, output window. A lot of the toolbars and things look the same as well. Build windows.
Yep. And the application developers, as I mentioned, can then, after they've generated this exe, they can hand it back to the platform builder people who can take that exe and roll it in as part of their nk.bin for the binaries.
Or if you so choose, if you wanted to distribute this application that Jonathan's creating, you could actually create a CEC file for the exe that describes it, and it could be imported into the catalog. And then anybody that's using Platform Builder could drag and drop that component into their platform, and it would be built as part of their custom Windows CE platform. So we're really enabling an iterative process here with application development through using Platform Builder, SDKs, and application tools.
Okay, and here's the application now running on my CEPC. And as you can see, all the same things, the common controls, like the file dialog. This is a debug build, so it's going a little slow here.
Actually, we're going to need to switch it over to show it on the screen.
Huh? Oh, I thought I had already. I have it?
Yes, you did.
Oh, you need to go to 3, sorry.
Great.
There we go.
So this is your application running on the CPC?
Yes, with all the same common controls that a very rich set of controls already present on the SDK and the platform that you just built for me.
Very cool. Well, this is an interesting feature. So we're really enabling application development against embedded platforms through this export SDK feature combined with the app tools.
Correct.
Thanks a lot for sharing.
The other thing is, if you want to build an open development environment, you can then publish this SDK out to the web so that any developer could download it and use it with the toolkit. That's another possibility.
Good point. Thanks a lot for joining us.
Thank you.
See ya. Okay, so the last demo I want to do today before we open it up for questions is to show the new features that we have in debugging. So with me today is James Stultz, who's the development lead for debuggers and some other things in the tools group. And he's going to, again, demo the IDE kernel debugger.
Hi, Dave.
How you doing, James? Okay, so the first thing we're going to have James do is set up a debug environment here. What you're going to quickly see is that it's pretty much the identical thing you're going to do that Steve went through in terms of setting up eShell. The thing he's going to change here when he goes into eShell is that we're going to choose a new nk.bin. So like the other demos, we've pre-built a debug-ready platform so that we wouldn't have to sit through that here. And so James is now going to that particular flat release directory and grabbing the appropriate nk.bin so that when we start up CESH or CE shell, it downloads the debug image down to the CEPC target.
Is that right?
Yes, so CESH-E again for Ethernet, and then he gives it the machine name. And then we're going to boot our CEPC. Do we need to switch it? Yes, we're going to reboot the CEPC.
I also have to select a project to debug here.
Okay, so we're going to select the nk.exe to do debug here for our demo today. And James is going to reset the device.
Okay.
So again, so far the process has been identical to when we had configured and built and downloaded a retail image, except we pointed to a different NK bin that had been built specifically for debug. You're going to see the same boot up sequence here. Go ahead and hit enter. James selected an NK bin that was in his x86 debug directory for the platform which he loaded, which was CEDevCon 2. So while this is getting set up, why don't we talk a little bit about how you enable your environment for debugging? There's really three things that you're going to want to do. The first is, as Steve mentioned, in the IDE itself, you have different configuration options. So if you want the full set of symbols for the OS, you can select a debug configuration and build for that. The resulting nk.bin is going to be a bit larger. You might want to restart that. Are we going?
Mm-hmm.
Okay, the second thing you're going to do is, as I mentioned, you're going to need a debug stub on the OS. So this is a lib called kdstub.lib. And the way that you add this to your image is, since it's statically linked with the kernel, if you're on the command line, you have to pass a parameter image no debugger equals. And that will statically link kdstub.lib into the kernel and enable debugging for your platform. In the Platform Builder IDE, we make it a bit easier in that you can go to the project settings, and in the environment variable tab, or the environment tab, just there's already the image no debugger set as a default to 1. So you just change the value to nothing and apply it and rebuild your platform. And then you will be enabled for debugging. But there is another option. So if I would build, maybe I want to debug an app, but I've already built a release version, and I don't want to rebuild with this environment variable, image no debugger equals. Is there something else we can do, James?
There is. We support a utility called loaddbg, which allows you to dynamically load in the kdstub at runtime.
Perfect. So what are the things we're seeing here right now in this output window?
This is all the output that is coming out of the debug output strings that the operating system has for the debug build. In addition, with the load notifications that we're receiving as components are being loaded.
Perfect. Now, I mentioned earlier there's 3 things that you do to enable debugging. The third thing is, in our case, we're doing Ethernet debugging. And the debugger defaults to the COM port, which is serial. So we set a second environment variable, or setting, in the IDE, which is eboot. And eboot, again, if you're using our new IDE, if you go to the Platform Settings Environment tab, you'll see eboot equals, and the default is set to nothing. You would set that to 1, and again, rebuild your platform, and then you'll be able to do Ethernet debugging. So now you can see this is based on a min shell configuration. So the image is now up. And so I want to show off this debugger a little bit. So let's do some basic stuff like set some breakpoints and sources, like the keyboard driver. But
Okay.
I know before we do that, we have to actually be stopped. The system is going now. So how do we do that?
That's right. What we're going to do is we're going to break in the shell to cause an interrupt to happen so that we can stop the system.
So this is a hard-coded breakpoint?
This is a hard-coded breakpoint that's defined inside the shell.
So now it's asking for the sources, correct?
That's right.
And if we don't have the sources, which we don't to the OS, we can just say cancel and we'll go to disassembly.
Sure.
So as I mentioned, let's set a breakpoint in like the keyboard driver.
Okay.
We do that, so we need to load that up.
So you'd want to go and look for your source that you're going to set your breakpoint in. And the particular sources that we're going to set our breakpoint in is under the platform directory, CEPC drivers, the keyboard and mouse drivers, the common, and we're going to actually open up this source file and look for a place to set a breakpoint.
Well, why don't we set a breakpoint when I hit a key?
Sure.
So like a keystroke.
We'll set a breakpoint right here on this line right here.
And we set breakpoints. And notice that, again, this looks just like an application debugger in terms of the UI, the way you set breakpoints, the way you say go, etc. So now that we've got the breakpoint and that we need to say go to restart the system, correct?
That's right. Now the system is running and we have our breakpoint in place.
Okay, so can I go ahead and hit a key on the CEPC then?
Absolutely. And we hit our breakpoint.
Great, so there's our breakpoint.
Okay.
Well, let's see what's coming up in the code here. This looks like a member function, but I don't know anything about that code at all. So, and I don't know where that code is in this driver. So is there some kind of trick that would take me to that function?
There are a lot of cool features with the VC6 debugger, and we've incorporated all of those within our kernel debugger. One thing that we can do, since we're looking at a member function here and we don't know where it is in source, we can switch into disassembly mode, grab a hold of that symbol, because this symbol is just a symbol and an address, drag it, drop it into the disassembly window, and it has already opened the source file for that routine. And then we just switch back into source mode.
So now that we're back in source mode, we're in that function.
That's right. We can do our inspection. We can set breakpoints here. We can do whatever we want to do.
Now we can do we can step in.
Sure.
etc.
If now we're back into our original spot, we're going to just go ahead and step into that routine. We can take a couple of steps, do whatever we need to do.
Now I notice one of the icons there that I don't remember being supported in WinDBG is to step out.
That's right. We support all the VC6 IDE debugger features, so step out is also supported.
Perfect. Now, again, kernel debugger is a bit different than an application debugger. If I'm just debugging an application, I'm debugging a single process. And so all of my debugger windows are specific to that process. I'm going to see the thread stack, for example, for that process. But we're doing kernel debugging now, so we need to be able to see the entire system. And in fact, that's going to affect us. So
That's right.
we've re-engineered some of the debugger windows. For example, can we look at the process window?
That's right. We've added a new button to our toolbar called Processes, and this will display all the processes that are running on the system at this point.
That's great. So this is a list of all the processes. What happens if we click on one of those processes?
You can click on any one of the processes, and it will display all the threads in the second window, and the call stack in the bottom window. So you can switch through any one of the threads, showing you what the call stack is.
The call stack for that particular thread.
That's
Now,
right.
I remember when we used WinDBG, there was particular extensions for that. Like there was a bang process.
Bang process would have provided you the list that we show on the first pane up on the top.
So instead of having to type in a command line bang process on a particular process, we just click on that process and it automatically does a bang process and lists the thread stack.
That's right.
I can click on a particular thread and it unwinds the call stack for me.
That's right.
And then I can click on a function within the call stack and it'll take me to the source.
Absolutely. If you had the sources for this, you would be able to see the sources for that call.
This is really great. So we've essentially taken this command window-based kernel debugger and we've integrated it into the IDE, and by doing so we've now assumed all the benefits that we had in the application debugger. So all the little tricks that developers have had for many years using C++ app developer can now apply those same things to the kernel debugger.
Absolutely.
Great. Well, that's really interesting. So appreciate you coming up and sharing it. So that concluded the demo portion of the presentation. I would now like to open up the last few minutes here. I think we have until 12 o'clock, or 1 o'clock rather, to take some questions. If you have a question, we'd really like it if you'd go to the mic, and we'd be happy to answer it. For those of you not staying, we thank you for showing up at the Platform Builder presentation.
Hi. First of all, the preview release of the VC Toolkit and the Platform Builder, on which CE version do they work?
The toolkit? The VCCE toolkit that you're talking about?
Both of them.
The Platform Builder 2.1.2 supports version 2.12 of the operating system.
Okay, and
the preview that you just saw includes Birch SP2 support for the processors in the VCCE, the applications.
2.12, the same. So
the
it's
same,
saying,
okay.
Yeah.
Right.
And what happens with the CEDar release?
The Sega?
CEDar?
The CEDar?
CEDar release? Well,
Yeah.
there will be another version of Platform Builder. So the ship vehicle for the operating system is the Platform Builder. Platform Builder will have another release to support CEDar in the future.
But right now with the preview we got a preview of the CE3.
Yeah,
so, can I take this one? The CEDar preview that you got was for a particular purpose. It was to exercise the real-time functions of the kernel in CEDar. It wasn't really a tools release, so there aren't any corresponding application development tools available for that CEDar preview. And in fact, when you install CEDar preview, you're going to see that it's an older set of Platform Builder tools. It's the version 2.11 tools, and we did that so that, again, the purpose of that preview is specifically to be able to just build and exercise the operating system to test out the real-time kernel.
Okay, second question. Do you still need, if I want IDE, Platform Builder, IDE debugging, and application debugging over Ethernet, do I need 2 cards or 1?
The one Ethernet card for the debugging and downloading would be dedicated for the kernel. So like in a CPC example, you would have 2. You would have an application Ethernet card as well.
Okay, and the application Ether card, can I still use it for running applications and debugging at the same time?
You would be able to use it as an application debugger for Visual C++. Like if you rolled an SDK, or if we provided a target SDK that supported that, you would still be able to debug both the kernel with one Ethernet card and the application with the application debugger on a separate Ethernet card.
Okay, but the second Ethernet card, can I use it also for a standard application working over that Ethernet?
Absolutely. The application debugger has never required the whole Ethernet. I mean, it's just WinSock based.
Okay.
So, I mean, the kernel has to have a dedicated port, but the application debugger doesn't.
Okay, thank you.
If I roll an SDK for using the application debugger in VC plus, not the low-level debugger, not the WinDB debugger, can I do that with a single serial port as my transport? In other words, no CESH. For example, like you do now with handheld PCs where they have only a single serial port, but this is my embedded device, and I only have a serial port on it when I release it. but I want to allow third-party application developers using the high-level application debugger to do that.
Yes, we still support the PPP connection. So that's basically you would roll your SDK, you could provide it for Visual C, and then Visual C would then connect on that PPP line, which is your only serial line.
And that would be for both application download and debug.
Application, yes.
Yes.
Okay, thank you.
You would also need to include the ITL transports in your nk.bin image.
ITL?
Platform manager.
Okay. And can that be a 3-wire serial port, or does that have to have hardware handshaking?
I don't know the details of the transports themselves, but if you've gotten, I mean, I'm assuming that you had this platform debugging with previous tools?
Right now I'm debugging applications in 2.10 and 2.11.
Successfully on that?
With WinDBG.
Successfully on that?
Successfully with WinDBG with just a serial port, but I can't do it.
Well, that particular serial port must be dedicated then. That isn't the serial port that you're talking about.
Right, I would have a second serial port, but I just want to know that I can do it with a single serial port on my
If you can
release
do it
device.
with WinDBG, you can do it with your other serial port.
Okay, thank you.
I got a few questions. First one, on my NT machine, I have the previous version of Platform Builder installed and embedded toolkit and Visual C++ 6 and all that. So if I install the preview of 2.12, how many things would go terribly wrong?
What was the last part of the question? How many things?
How many things would go terribly wrong?
Well, we do test that the newest versions of our tools don't stomp on older versions of the tool. So we install it to completely different registry settings and directory structure. So you shouldn't have a problem with running the preview. But if you're building a production, it is a preview. So if this is your main development machine and you're developing a platform with an older version,
Right.
just to be safe, I would recommend keeping them separate. But we do test that they don't stomp on each other.
Right. Second question is LoadDBG supported on the ARM processor?
No, it's not. That's the only one that's, oh wait, in 2.12? I have made the correction, but I can't remember whether it was in 2.12 or whether it's in CEDar. So I would have to get back to you on that.
All right, and the third question is somewhat involved. Windows C, if I understand correctly, there are 3 licensing modes for Windows C. There's one with a minimal kernel configuration, there's one with everything, and there's one in the middle, and there's different prices for everything, for all 3. So what we've done, we have a project which is in the middle, but unfortunately, it's none of the predefined, pre-canned configurations. So we went through the exercise as prescribed by the Microsoft documentation of removing the components that cannot be in the middle configuration without paying an extra license. And we found that some of the components are relying on the components that have to be in a Maxell configuration. So we were not able to build a completely kosher system that can be licensed. So first question is, I don't know what the reason for this is, and I don't think you can answer that at this point. But a question to you as tools developers, is there a GUI tool, or are you planning a GUI tool that can show a complex interdependency of the components? I can say, if I'm pulling this thing out, what will break after that?
The dependency analysis within Platform Builder is definitely something that a lot of customers have asked for, and we're looking at for future releases. It won't be in the 2.12 version. And the first part of your question is, I would recommend talking to the Core OS team about the licensing levels in terms of the middle. If you pulled out the modules to get to the middle license, you didn't have something that worked. Talk to the OS team.
There was, some silly function like core string A or something like that.
Yeah,
string length.
Yeah, I think they are aware of this issue, and but I would recommend, there's an Ask the Expert session in just a few minutes here, and I think it's in Exhibit Hall A. And if you go up there and talk to the Core OS team, they'll have representatives there that can give you some better explanation.
Well, is there at least a tool that can show which functions are used
No,
from what component to what component?
The short answer is no. There's currently not a tool that breaks down all the complex set of dependencies within the OS. But again, it's something that lots of people have asked for and we think is very important, and we're looking at it for the future releases.
So what is a tool we can use? Let's dump the header and look at the header. sort of export, import?
It's trial and error, and that is one of the reasons we ship with 8 standard configs, and we allow you to modify those configs within Platform Builder or within your csystem.bat. There's safe ways to modify your configs, but when you start making major modifications to the configs without the detailed dependency analysis, there's risk. So it basically becomes trial and error.
And unfortunately, the pre-canned configs, there's no connection between them and the licensing requirements.
I hear
Right.
you. Yep.
All right, thanks.
Feedback taken. Thank you.
What is the, sorry about that. What's the easiest way to convert from my current ETK environment to the new platform builder?
What kind of change you have made?
I'm sorry? I didn't-
In your current environment, what kind of thing you have been doing?
I'm actually just doing a max haul, but I'm more concerned about my platform files, how to get them into the current system of 212.
The command line environment that you used to cannot be easily converted to the IDE. But for all your source files, project files, you might be easy off by just creating a new platform from scratch, because creating a Maxor config is not that difficult from the IDE anyway.
Mm-hmm. Okay, thank you.
Thank you.
Yes, you've had several speakers here talking about how important it is to automate builds. Are you going to have the ability to automate the exporting of an SDK?
This question has been asked yesterday, and the answer is no. But we are looking at that probably in a future release, adding that as part of the scripting model, so you can use a script to drive the IDE to do whatever you want, and export SDK could be part of it.
So if that's all the questions, again, thanks for coming, and we'll be up here for a couple more minutes if any of you want to stop up, ask anything additional. Thanks.